Hi guys, it's Kate. This is a look at the second two-step quiz for Math MA and how to go about answering one of these questions with an eye to the rubric and how to transmit your mathematical ideas into writing in a really clear way for the reader, which is the emphasis for these quizzes. And what's interesting is that these quizzes are not graded on correctness. They're graded on completeness, on thoroughness as far as how to transmit your ideas. And this is how we hope you're able to tackle sort of any problem that comes your way, because it's not always 100% clear how to solve a problem right from the start, whether that's on a problem set or on an exam. It can be difficult. So the idea is to get your problem solving skills in order in a way where you're really thinking clearly about everything. Let's take a look at this problem. It says you're helping to design a skateboard park, and below is a graph that is part of the design. Skateboarders drop down from the platform 3 meters high that's shown on the left. So this piece right here, that's the platform. And it says they are slowed down by a ramp shown on the right. Okay, so far so good. Even as a reader for the first time for this question, I'm still a little bit confused why there's this huge empty space in here. And then I keep reading and it says you want to connect the platform to the ramp on the right via a graph of a quadratic function so that the curve you get is continuous at both x equals 2 and x equals 4. And that's a lot of information. I get that I need to connect the two, but what does it mean for a function to be continuous? I need to remind myself at this very moment. And so I quickly jog my memory, which is that a function is continuous at a point A if the limit from the right and from the left agree and the function value there is equal to that limit. That basically means I can have corners and cusps, but I can't have asymptotes, removable discontinuities, jump discontinuities, so corners and cusps are fine. It says that I also want the slope of the tangent line to the graph of the quadratic function to match the slope of the ramp so that it is a smooth ride. So that's definitely challenging. I can tell that that means it's going to have to be a parabola, and I saw that in a lot of the drawings as we were grading the two-step quizzes. There's going to be an allowable corner up here, but this connection has to be smooth. So I'm going to give it a shot and try to draw this first, what I'm trying to find, the quadratic function. And then we'll see different things I need to do, because down here next to number 1, it tells me I have to find an equation of the quadratic function that would connect the platform and the ramp as it's required in the problem. So I've annotated this diagram with all of the different pieces of information and taken a couple of notes for me to really figure out what I'm trying to do before I am even given my goal of the problem. I'm trying to picture exactly what's going on. It doesn't have to be smooth over where it connects to the platform, but it does have to be smooth down by the ramp, and it does need to connect to the two. So now my goal here is to find an equation of the quadratic function that would connect to the platform and the ramp. My first job is to sort of understand that goal. Well, a quadratic function, the family of quadratic functions rather, take on a particular form. They have some quadratic term, x squared, some linear term with an x, and some constant term. Now, sometimes the coefficients on the linear term and the constant term are 0, but overall, I successfully recall that a quadratic function is going to be of the following format: ax squared plus bx plus c. And this quadratic, my goal here is to find a quadratic that is of this format and then also does the following things. One is that it's got to connect the platform to the ramp. So that means that it has to go through these points, 2, 3, and 4, 1. I also know that where it connects to the ramp is smooth. So the slope of the tangent line to the graph of the quadratic function, meaning the derivative of the quadratic function, has to be the same as the slope of the ramp. And I write that down in the following way, because I notice that right where the quadratic and the ramp connect, which happens at x equals 4, the slope of the tangent line to the graph is the same as the first derivative for the quadratic. So I noticed that the slope of the tangent line to the graph is equal to the derivative, so that means we're looking at f prime, and where is that f prime that we care about? We say that we want the derivative of the quadratic at 4 to be the same as the slope of the ramp. And I can take a look and notice that when the ramp increases by 1, when x increases by 1, rise increases by 1/4. So the slope is going to be 1/4. And we know that these are the 3 pieces that need to happen. This is so that we connect to the platform up here. This is so that we connect it all to the ramp down here. And this piece is so we connect smoothly, so that the tangent line to the graph of the quadratic matches the slope of the ramp so that it is a smooth ride. Now, what's my plan? Well, I have all of these pieces of information that say, hey, when I plug in 2, I should get 3. When I plug in 4, I should get 1. And when I plug in 4 to the first derivative, I should get 1/4. I'm going to get a whole lot of equations out of this statement of the quadratic. And I think that with those 3 different equations, because I have 3 different facts, I'll have 3 unknowns in 3 equations. And I feel like I might be able to solve that system of equations. So my plan of attack is to create statements out of these, follow these and apply them to this general form of the quadratic, see what kind of expression I get, and try to figure out what A, B, and C need to be given what these 3 facts tell me in the context of this particular function. All right, let's get started. Let's apply that first fact, that when we plug in 2 for x, we should get out 3. All right, so that first piece, that's going to manifest itself in the following ways. If I plug in 2, I should get out 3. Okay, let's take a look at the second piece of information, that if I plug in 4, I should get out 1. All right, I was able to apply that and simplify it down to this expression. And the last piece is that if I take the derivative and evaluate it at x equals 4, I should get 1/4. Now the question becomes, what is the derivative of a quadratic function? Well, we know that the derivative is 2ax plus b. So let's apply this to when x is equal to 4. All right, I've done the first step of my plan, and I want to take a step back and look at what I've got so far. I have 3 different statements. I have 4a plus 2b plus c equals 3. I have 16a plus 4b plus c equals 1. And I have 8a plus b equals 1/4. Now that's 3 equations with 3 unknowns, which means that it should be solvable. I'm now going to say as part of my plan that I'm going to try to solve this system of equations. Let's do it. I can see already that there are some options for me. One is that the first and second equations, this one and this one, can be subtracted from each other and will eliminate c. So I'll be left with an equation involving a and b from subtracting these from each other. I have another equation involving a and b over here. And so then I'll be left with a situation with 2 equations and 2 unknowns. I'll solve for a and b, and then I'll backtrack and solve for c. That comes from my experience in solving systems of equations, looking for a variable that can be eliminated. That's what I'm doing when I'm looking at how to subtract c. So let me give that a whirl, and then I'll reassess once I've done that. Sure enough, after subtracting one from the other, I do have an equation in 2 variables, a and b. I'm going to clean it up a little bit by dividing by 2. And in fact, I'm super lucky, because then I can just use this equation, add it on to this one, and eliminate b and solve for a. Let's do it. And lo and behold, we can solve for a. Dividing by 2 on both sides, we have that a is equal to 5/8. Now backtracking through this, we can plug that value for a into either of these 2 equations and determine what b then needs to be. We're able to do that pretty easily. There's sort of a moment here where we do need to understand that 5 is 24ths, so when we take 1/4 and subtract 24ths, we're getting negative 19/4. That's for b. And last but not least, we can use either of these first 2 equations to then solve for c. I'll probably end up using the first one just because the coefficients are nicer. By simplifying both of these terms in advance into 5 halves and 19 halves, it's much easier to figure out what C needs to be. All right, I've solved for A, B, and C. And so my answer is apparent to me. I'm plugging it into our original quadratic format, and now it's going to be 5/8 x squared minus 19/4 x plus 10. Now, what would a reasonability check be? Well, I want to make sure that the 3 things I need it to do, it's actually doing. I need to make sure that the function value at 2 is 3, the function value at 4 is 1, and the first derivative at 4 is 1/4. Let's do it. Sure enough, the first function value checks out. It evaluates to 3 when we input 2. Let's make sure it evaluates to 1 when we input 4. It sure does, and the last check is to make sure the derivative is 1/4 when you evaluate it at 4. Well, I had to use the power rule to find the derivative as it was. Then I plugged in 4, and sure enough, I got 1/4. So yes, this is my final answer. It does all the things I want it to do. The big key of a 2-step quiz is that I'm extremely explicit, even with the reader. What is going on? What am I thinking? And at individual points, it's not so important that at the top of the problem I'm able to see every single thing from start to finish, but that at each individual juncture, I'm saying, okay, I'm going to apply these 3 facts and then see what happens on the other side. Okay, I have these 3 facts. Okay, I'm going to try to solve the system of equations. Okay, I'm going to try to eliminate here. Okay, now I'm going to determine B. Now I'm going to determine C. Now I'm going to go back and double check everything. There isn't this pressure to know exactly how the problem is going to work out from the very start. Rather, it's a constant ability to describe exactly what the thought process is. And we really do want to see goal and plan on your piece of paper. And even if you get stuck, say explicitly why you got stuck. Maybe I'd made an algebra mistake here and I couldn't solve this. And I would say this system seems unsolvable, but there's nothing really about this particular situation that seems like there wouldn't be a quadratic that could do this, so maybe it's an algebra mistake. Maybe I need to go back and sort of go back a few steps and try to catch where I felt confident up to and then pick up again and keep working. The big thing that we want to see is in the group submission, you don't want to just blow through everything and try to get the right answer and get through the problem as quickly as possible. Really organize your thoughts, talk about your plans explicitly, and to show these checks, those are really important as well. Do they make sense? Is there something that you can eyeball? Maybe you didn't get far enough, but you got that A was some negative number. Well, that doesn't make sense because way up at the top, the quadratic is upward facing, right? It's not downward. It's not a downward facing parabola. So there's no reason why A would be a negative number. So there are little things like that that you can do. But here's a completely worked through 2-step quiz, and I hope you find it helpful as you're preparing for your 3rd and final 2-step quiz on Wednesday. Have a good one, guys. And of course, email if you have any questions at all.